One of the ideas is actually to try to introduce these kind of small power systems into developing countries where there's a lot of need of new ways of producing or converting energy into electricity. Organic Rankine cycle turbines are turbines that work exactly with the same principle as a large steam power plant, but the working fluid is an organic fluid, like a refrigerant fluid similar to the ones that are used in domestic refrigerators, so to say. Or, and this is even better, light silicon oil. The use of these fluids allows for the design of small power systems. There are various reasons for which you cannot really use water as the working fluid if your target power is in the range of few kilowatts up to, say, 1 or 2 megawatts. The interesting thing, as it is the case for the steam power plants, is that you can use an external power source, which means you can use a solar collector to heat up the fluid and then expand it in a turbine, or you can use so-called dirty fuels like biomass, for instance. Biomass is dirty not because it's bad, but because when it burns it produces particulates, things that you could not expand, for instance, in a gas turbine. I have several projects dealing with development of organic Rankine cycle turbines. We mainly deal with the fluid dynamic design of the turbine and of the heat exchangers. I submitted recently a fairly big project proposal to develop the so-called supercritical organic Rankine cycle. Supercritical with respect to the pressure and the temperature of the fluid. This is to make the thermodynamic cycle even more efficient and the resulting device more compact. This would enable, for instance, the use of solar concentrators with this kind of device. You could think of assembling this turbine and the auxiliary equipment in the focus of a parabolic mirror and then produce electric energy. I recently came into contact with a professor in California who developed a very nice static solar concentrator, much cheaper than parabolic tracking mirrors, which again prompted me to the idea of designing a system for developing countries. These systems are inherently very reliable. They are made of conventional heat exchangers and a slow rotating turbine. The working fluid is a lubricant itself, so a very small amount of parts. In my mind, it makes it a perfect application for developing countries. You can think of a system that can be powered by, for instance, agricultural residues that are collected by people from a village, for instance, and then burned into a simple furnace, and the turbine generates electricity for the village. It could provide light to children who want to study at night, which I understand from some Indian colleagues is really an issue in countries like India, because unfortunately very often young people need to work when there's daylight, and they would be very willing to study in the evening, but there's no light. It can be more sophisticated than that. Of course, electricity could promote simple manufacturing, and that empowers people a lot. Electricity can be used to pump water, and you can think of solar system powering pumps for irrigation. One of the companies I'm working with developed a solar system that was then delivered to Congo, if I remember, and it's been in operation for a couple of years, and then it was destroyed by a civil war. I am fully aware of problems like that in those countries, but that doesn't prevent anybody from trying again and trying harder.